In this video, I want to give you an introduction to my static site generator, nsg. And first up, I want to kind of talk about what differentiates it from other static site generators, and also like why should you care. I think the main point, or one of the main points, is that here there is no like pseudo scripting language, like with other like static site generators or also like templating languages and all that. For my static site generator, I use Scheme, which is a dialect of Lisp, and then in particular I use Chicken Scheme. So when writing like templating code or also components, you have a actual like real life programming language at your hands, and not some scripting language that has like a few features and but not like all of them features, and to implement a new feature, to add a new like operator, you need to go into the code base and whatnot. No, not at all here. Also, there's no plain HTML, because, I mean, look at it. Plain HTML is really a pain to work with because it's so verbose, or rather XML. So I have opted to use SXML, and you can also see the syntax for that. So SXML is basically, yeah, it's Lisp. So it uses the same syntax as Lisp, and also as Scheme, of course. So there's a really great blend, and I will show you this in a second, or further on when we get to examples. There's a great blend between your logic and your data, and this makes it really great to work with, because you have like one syntax for everything, and thus you can also, it also integrates very nicely with your editor. So most often you will probably use Emacs with PowerEdit for this, but I'll show you in a second. Also, there are LaTeX and GemTech exports, and so GemTech is the default kind of data type for the Gemini protocol. And so you can have one kind of source of truth, quote unquote, for example, well, most likely, or in most cases, you will use this for like articles or blog posts or stuff like that. And you can export it to 3 different formats: HTML, GemText, and LaTeX. All right, so next up, small code base. If you look at big projects like, for example, Hugo or something like that, their code base needs to be very large, because they need to have like all the fancy features and all this kind of stuff. It tends to get very complex. Not so with this. I have only integrated or added all the features that I need, and I think the code base is quite small, and it also allows for like easy extensibility and to be able to easily change something to one's own liking. All right. This is kind of the table of contents for this kind of presentation. First up, I kind of want to talk more about my motivation, because this was kind of about what differentiates NSG from other static site generators, but about my personal motivation, why I wrote this. Then I will show you the usage, so how to actually use it, and also minimal examples. Then I will show you a real-life example, so in particular my own website. Then I will go through some of the code, like the basic building blocks, let's just say. So I will, of course, not go through all of it. I will show you how to install it and how you can use it yourself. And at the end, I will close with some more thoughts. And for the motivation part, I will stay in this send presentation, and then I will switch to my desktop and, yeah, show you how it works. All right. So motivation. Like, why did I even write like a static site generator when there are so many of them out there? And I think it all boils down to like control over tooling, because so I have used Hugo before I wrote this, and I was getting really kind of frustrated because I didn't have all the control I wanted to. So for example, the kind of directory structure was kind of annoying me, and also that I had to write like plain HTML and all this kind of stuff. And I was not able to easily understand and change anything, really. So to be able to actually change something, for example, in Hugo, I would have to dig into the code base. I would have to, okay, where do I even start? Like, what's the main source file? Like, is there a main method? If so, where? And so on and so forth. I would have to learn Go. I would have to install the entire Go toolchain and all this kind of stuff. And this all boils down to like minimalism, as in not including anything that I don't need. So I is bold here. Or kind of pseudo bold. So meaning like in Hugo, let's just take Hugo as an example. I mean, you can replace it with anything. It can do a lot of stuff. Like, it has a lot of features, but most of them I will not need. So, and by building something myself, I can include only that which I need. So everything that is in NSG right now is something I need. Okay, so this point I already touched on in the beginning, like pseudo scripting languages and HTML. Again, I mean, I don't really have anything to add here much. But like these pseudo scripting languages where you have like curly braces and then you have like some hard-coded operators, it's kind of annoying. Like you have this with like, for example, also like templating languages, like what's the one Flask uses, Jinja or something like that, and all this kind of stuff. And it's really, yeah, it's just like unnecessary in my opinion. So Scheme and SXML work perfectly fine together, and then you have all the like power you need. You have the entire power of Scheme, and SXML is like a perfect drop-in replacement, quote unquote, for HTML. Also, this is a huge point: no fragmentation. So one use case I had was using Hugo with Tailwind and or Uno CSS, and this was kind of really annoying me because there is no, you would have to search it on the internet and you would find like one forum post and there would not be like any, like, and it would kind of cover the use case for Tailwind, but not for Uno CSS and so on and so forth. Like you are dependent on other people and the solutions they have built, because again, to like, you can't easily change something because the project is just so huge. And also I wanted to be able to export to different formats. And I mean, you can kind of do this if you write in Markdown and then you use Pandoc or something to convert it. But like for Gemtext, so for the default Gemini MIME type, there is not really, there aren't any Pandoc filters. I mean, there are like third-party filters, but they don't work like perfectly and they don't work like I want them to work and so on and so forth. So yeah, it all boils down to control over tooling, I think. All right, so enough of the motivation thing. I will switch to my desktop and I will show you how NSG actually works. All right, so on the left I have Emacs, and on the right I'm in a demo directory, and in here I have one file, and this file is open here. And so NSG, by like how I have structured the program is I have one like kind of root program, NSG, and then I have syslinked them, symlinked that program to 3 programs: NSG HTML, GMI, and TeX for LaTeX, Gemini, and the HTML. And you need to call it with, like, you need to call these symlinks because it checks for the name of the program. So yeah. And if you just type NSG, for example, HTML, and then the hyphen, it will read from standard in. So I will, I will create a minimal program here. So it always starts like .nsg files always start with an environment for variables, and then this kind of separator. And this separator is important, as I'll show you in this demo. So it also always starts with this, and this is now an empty environment, but we will populate it soon. And then we have just, for example, some text. So, and if I save this and now cat this index.nsg into our NSG HTML with the hyphen, it will spit out the HTML code. So a paragraph with some text inside it. And we can of course also call this with, call this without any like pipe, and it will just read from standard in. So if we now, for example, some more text, do this, and then hit Control D, it will do the same thing. Okay, so far so good. But normally you don't want to, like, at least for my project, I don't really have a use case for like piping it into the program and then reading from standard in. I just want to like have it convert files. So, and the way you can do this is also pretty simple: NSG HTML and then index.nsg. So the file we are currently working on. And if I do this, it doesn't give us any output, but it creates this index.html file. And if we now open that, for example, down here, so index.html, we see, well, it's the HTML we also got on standard out. So far so good. And we can now also, because there are no HTML specifics right here, we can now also export this with Gemini or LaTeX. So if I do this, I will create the GMI, and if I call it with TeX, it will create the LaTeX file. So if we open that up, where is it? Here. this is just some text, and the LaTeX file will also look the same because there are no, there are no syntax things, or there's nothing to convert here. So if we now, I keep hitting the super key, excuse me, let me just turn this off. So if I now hit, for example, do some italic text and save this, we can again convert the HTML and look at that. So if we change on disk, and it has now created again a paragraph with some, and then a span which is italic with text inside it. And now you might wonder, well, what kind of markdown is this? And so in the first version of NSG, I have used markdown or org mode, and I then use pandoc to convert it. But for this new version, I have written my own kind of markup format, you could say. And I will go into that in another video. But yeah, for this video, it suffices to like, I mean, this is not about the markup, but about the static site generator itself. All right. So cool. What can we now do with it? Because as it is right now, this is not a site. Like, this is just a p tag. So one of the most fundamental things you can do, or you need to do with NSG, is you need to specify a layout. So, and how you do this is, let me make it a bit smaller, is by setting the layout variable. So let's do it like this, and let me actually activate scheme mode here. So what a layout is a function, or what it needs to be is a function, so a anonymous function in this case, which takes one argument, content, and which kind of wraps this content. This is like the idea. So we can do it like this, and then it needs to return something. And right here, we need to kind of, if we do it like that, we need to decide, okay, what do we want to export as? Because the layout needs to be in the corresponding like thing. So it needs to be HTML, or rather SXML, or it needs to be LaTeX or GemText. So I will show you first HTML, and then I will show you how to split it up so you can export to all formats at the same time. So, and we want to then return some SXML. So for example, we could return HTML, body, and then our content. So like this. If we now do like this and revert this buffer, yes, we see, okay, our p tag is now actually wrapped inside this body tag and then inside the HTML tag. So exactly as we specified here. All right, we could now also, for example, add an h1, hello. And if we run this again and again, revert buffer, yes, we see there's now also this h1 present. All right, so far so good. But we are only still like operating on one file. We don't really have a directory structure. Like if I ls here, there are still this kind of flat directory structure, and that is normally not what you want. What you normally want is you want to have at least what I want to have is a content directory and then an output directory. So in the content directory, I have all these NSG files, so all the specifications of my content, and then I have an output directory for, well, the output files, so the HTML, GMI, and tag files. So let's just do that. Make the content, and then I will move the index NSG file to content. And if I open that up again, and scheme mode would be nice. And if I now convert it, it will convert the file in the content directory. So what we need to do is we need to specify an output directory. So we do this with output D, and these kind of start variable names, these are variables that NSG understands, or at least that are kind of hard-coded into it, you could say. And I will show in a second how you can like define your own variables that your program uses, or your site generator, or your site rather. So output here, I normally use out as the directory name, and I mean you can use whatever you want, of course. And if I now do nsg HTML content index NSG, we see it creates an output directory, and let me remove all these index files. Output directory, and in there is now our index.html. So if we go there, we see it's again the same file, of course. So this is normally the structure I use, the directory structure. All right, now if you want to have more files, you don't want to have to specify like these things in every file. This gets kind of annoying very quickly, because it would all be output dir out. Okay, then the lambda, because you probably the layout, because you probably want to have the same layout for all your files. I mean, that's kind of the point, and so on and so forth. So what I do is I do the following: I take all of this stuff and I put it in a components file, I call it, and then I include this components file in here. So let's first do this, include, and then the components file. So I normally call them kind of comps.scm, so components.scm. And if I now open that up, so I create a new file, comps.scm, and put the stuff in here, and then I also need to kind of wrap this again in parentheses. So now this is one big list, and in there are these specifications for these variables. So let me go back here. So now you only need to have this statement in your file to be able to include like components or variable declarations from elsewhere. So if I now again nsg content index.nsg and kind of revert this buffer, nothing will change, because it's still the same thing. And if I now change something in this comps file, for example, hello from comps.scm, it will of course change it in the output file as you would expect. Revert buffer, yes. So hello from comps.scm, who would have thought? So this is very nice. Okay, and this is now also where we can have one content file, but export it to multiple formats, to GMI and to TeX, and also to HTML, of course. Because we can now, if I switch back to the index file, we can now have multiple or different includes. We can have, for example, well, not different includes, and not for example, we can have the following. We can have include GMI and include TeX, and also include HTML. And now, of course, we don't want to have like this, but we want to actually have different component files. So we could do, for example, this. We could have comps HTML, comps GMI, and comps TeX. And then we, of course, need to kind of create those files. So we could copy this to comps HTML, comps GMI, and comps TeX. So, for example, like this. And now we could go in here, or we can go in here and adjust this, because again, for GMI we don't want to have like SXML. That doesn't make any sense. But rather we want to have a string, kind of a string format. So we could use this. We could have, or we could just do string append, and then append, for example, some header information, and then, for example, some new line, then content, and then some footer. I mean, because gemtext is a text-only format, or plain text format, so we could have something like this. And now if we nsg gmi content index.nsg and look at the index.gmi file, we see, oh, there's now some header information here and some footer, and in between that is our actual content, which is just this, well, some text. So yeah, and the same of course works with the LaTeX export. So if I go into the components tag and kind of paste this in here, delete this, and now we of course don't want to have some header information, but we want to have like, well, actual LaTeX. So we could have, for example, begin document, I think it is, right? And then at the end we want to have, let's do it like this, end document. So I think this should work. And if we now do tag and look at the output, we see, oh, look at this. It's begin document, end document, and in between is some emphasis text. The emphasis is because this is, of course, italic, because of the forward slashes before and after it, after the text string. So yeah, and now you can call nsg GMI, nsg TeX, and nsg HTML on this one file and get 3 different output files. Now, sometimes you still want to have like some environmental variables, or some variables which you define here stay the same for all document types. So for example, this output here, what you can now do is, we could delete it from here, because this has nothing to do with LaTeX. This is not LaTeX specific, and also this is not GemTex specific, and also this is not HTML specific, but rather this is specific to the entire project. So what we want to have, is we want to still have it in this comps.scm, and now we can also include this general comps file from here. So like this, for example. So it always includes this comps.scm. For HTML, it includes also the comps-html.scm. For gemtext, it also includes comps.gmi.scm, and for LaTeX also comps.tech. So I hope that makes sense. And if we now call this again, we will see it exports just fine. So yeah, and if we look it out, of course here are our files, and we can now kind of cat them, and I mean, yeah. So this is the gemtext, this is the HTML, and this is the LaTeX thing. All right, so far so good. And of course now you oftentimes, well, always kind of most likely want to have multiple files, so multiple content files. And it would be annoying to have to include all of the stuff in every file. So I have kind of added a feature, you could say, to be able to only have to include it in the index file of a given directory. So what I mean is, if we, for example, let's copy all this. Oh, well, no, let's not copy this. So other page.nsg. So this is now a new file in our content directory. And here we will now have some more content, for example like this. And we don't specify any environmental files or environmental variables or something, but we only want to now have this compile. So content other page.nsg. And if we now call this, you see it works fine. And we can now look at the out and see, well, it actually does work fine. So it uses our layout, and yeah, here's also hello from comps.scm. So everything is perfectly fine as well, because it includes the environment of the index file. And we can now, of course, override from this file. So whatever we specify here will take precedence over our index file and also over all the component files. But I will show you in a second. Because we now want to, because this is still very basic, what you of course want to have is you want to have, well, actual components, because so far we don't have any components. And you also want to have variables. So for example, one variable would be title. Because if you write blog posts or articles, these normally have a title. So my other page title, for example. And to now access this title, you can use the following. So, and this is now where the kind of format and this kind of separator, which I talked about in the beginning, kind of becomes relevant. Because so far we have only converted this kind of markup format into the corresponding format and kind of wrapped it with a layout. But we can also now call arbitrary scheme code from within these separators. So whatever we call in here, this can be now any kind of scheme code. So we could now, for example, call 1+2. Or we can also access variables with this $sign operator. And this is now NSG specific, of course. This is in NSG. And this lets you access any variables you set, for example, here. So in these environments. So to now access the title variable, we just write title. So $title. And this will now access it. So if we now call nsg.html on content and then other page, and then look at the other page output actually, or look at the actual output rather, we see, okay, so everything is as before, but now we have this my other page title in here. And this is now not in anything. I mean, this is just plain text within this HTML file. So it just inserts it as plain text. So this is not really that useful, but it can be very useful if you, for example, if you use this title variable in, for example, the layouts or in a procedure, which I'll get to in a second. But first, let's use it in the layout, because that's one use case I, well, pretty much always have. So we can now go into comps.html, and we can now kind of change this, this hello from comps, we can change it to call our title variable. And so, I mean, if you don't know Scheme or SXML, this might seem cryptic. Yeah, I've made a video on SXML before. I would recommend you to check those out. But like what happens here is we say with this quasi quote here, we say, okay, just give me the following as is. So we want to have HTML, like this kind of what's called symbol as is, except the things which are quoted, which are not which are quoted, but which have a comma in front of them. And these should be evaluated. So we want to evaluate the contents symbol, and the content symbol corresponds to the contents argument. And this is, well, going to be the contents. And we want to also evaluate this expression right here. And so the $sign is a procedure, or rather it's a macro, and it is given this argument title. And this will return whatever title is. I hope that makes sense. So we can specify this. We can also, for example, go change the layout for the GMI. So for the gem text, so we can change, for example, we can remove this some header information and have it like this. So call title from here. And then we also may want to call title from the tech components. So, and now here we could have, for example, what's the syntax for that? I think it's let's just do it like this: format, and then title, and then we can here actually call our title. So this should work. So we want to call the title preamble thing and set it to our, well, actual title. If we now compile this page again now with our three things, so with our three output formats, and then look at it, so revert buffer like this, we can see, okay, HTML, body, this is standard layout stuff. And then if I switch to the HTML thing again, we see, okay, so now we don't have H1 with some hard-coded data, but we actually have H1 with the page title we set in the contents file of other page. So my other page title. And then again, the other stuff we've seen before. If we look at the other page.gmi, again, the same thing, my other page title, nice. And we can actually, let's change it to not be plain like that, but let's actually put a hash symbol in front of that, because that's the syntax in Gentext for a H1, for a header 1. And if we revert this, we now see it's an actual like H1 because there's a hash symbol in front of it. So pretty straightforward. And if we of course look at the tag file, oops, we see the same thing. So we set title to my other page title, and then we begin the document. So yeah, pretty straightforward. And we can of course do the same thing now in the index file and have a different result. So if we set title here to index, so like this, for example, and now again call it like this. And I mean, you probably want to create a script to automatically convert this on change. I will show you how we do that. So like this, and now look at the actual index. Yes, we see, oh, there's an H1 with index because that's the title we set here. Nice. So yeah, I hope it's clear how this works, kind of. All right. So, but we still don't have components. We still only are at the variable level. So let's say we want to have some arbitrary component for something. So something I always have is like a separator. So a separator component for when I write a text. I want to have a kind of split off sections, but don't want to use a explicit heading, but just some symbol to symbolize, okay, so this was one part and now comes another, you know? I usually have a component for that. And you can now either have components as statically, like a variable, or have them as have them in such a way that they take arguments, if that makes sense. But let me just show you. So let's go back to the components.html and let's create a procedure or a function, however you want to call it. Let's just make it, how should we call it? Let's call it my title. And it returns SXML, again with the quasi quote. And then we want to have, for example, an H2. and then let's actually make this a, yeah, let's make it no, let's make it statically first. So h2, and then we can of course again call the title thing, for example. I mean, this is kind of stupid example, or we can make it like h1, do it like this. This may be a bit more sensical. So like this. And now if we go into the, let me actually go down here, contents, index.html, we can now call this component, or insert it rather, like this. Oh no, wait. Let's make it a lambda. Sorry, lambda. But it takes no arguments because it implicitly takes this title. All right, to now call a procedure from your kind of environment, you can again use the $, but instead of $1, which would actually only give you this lambda, this anonymous function, we can use $2 to actually call this lambda function, or this lambda procedure. So if we do it like this, and then my title, let me make this a bit bigger, my title, this will now actually call this lambda function. So if we now save this, and now again convert this, and now look at the result. So let's go to out, and then index.html, yes. We will see, okay, now there's again now this h1, so nothing really has changed. So let's like do something that will show the change. So let's add an ID, title. The ID is title. So this is how you add like parameters or attributes to HTML elements in SXML. And let's put this on a new line, and this as well. And let's convert it again and revert this buffer. Revert buffer, yes. And now we see, okay, this is now an h1 again, but it now has an ID. So this is the actual, this is this SXML, because we of course called this my title procedure. And we can now make it like, we can give it a parameter. So title, for example. And instead of using, like, instead of looking in the environment for our title, we can now actually use the title which we get from the function call. So like this, and like my, or let's arg title, I don't know. So title from argument, basically. All right, let's do it like this. And we see now, okay, it's arg title. So yeah. And again, with title, this is now kind of a stupid like example, but I mean, you can think about how you could use anything with this. So I mean, you can set your, for example, in your environment, you could set your author or author name or date or title, of course, and all this kind of stuff. If we think about like writing text or something like that, but this is also, I mean, this is infinitely flexible. Yeah. So I mean, it's just components, and you give arguments to them, and yeah. If we now want to, for example, if we have some variable here, some var, for example, and we set it to some value, I don't know, and we now want to not hard code our value in here, but we actually want to like call this or get the value of some dynamic scheme expression. So for example, again, we can use the $, but we can also, for example, let's do something more complex. Let's get the value of the sum var variable, and let's append that, string append, to, for example, like this. Again, stupid example. No, sum var is like this, for example. And this will now not work because this $, these two $, don't evaluate their arguments. So this would not get evaluated. If we now want to evaluate this argument, we have to first get the lambda function and then call it again. So I mean, this is now kind of scheme. I mean, okay, this is all scheme stuff, of course, but without like having some scheme knowledge, you probably won't understand this. But okay, so we now get the lambda function, and then we evaluate the lambda function with this thing as an argument. So now this also gets evaluated. I hope that makes sense. Let's convert it, and I'll show you the output. So again, out index.html. And now we get some var is, and then some value. If we now if we were to now change, let's actually change this. So we could now, of course, change any of this. So if we change, for example, this definition right here, it would get changed in the output, of course. So let's add like exclamation points because this is so super important. Reword buffer, and now the exclamation points are here. I mean, I hope you kind of get how this works. But again, string append is now not a built-in like procedure into NSG or into anything I've specified in these component files, but this is now actual like scheme code which gets evaluated. Again, you could use anything here which you have in Scheme, which you have in this, like which you have in Chicken Scheme in particular in this case, and which is in the libraries you have imported and all this kind of stuff, which get imported by NSG and all this kind of stuff. But it's a full-fledged programming language, which is really like, I mean, for my use case at least, this is really like, this is kind of the greatest thing, because I was so tired of these templating languages which are so limited, and then you can have like, you don't really know, okay, what data am I working with? Can I like compare it? How does it, like with an equal sign, for example, can I compare strings, and so on and so forth? All this complexity is kind of hidden from you. But if you write a program yourself, like I have done here, you know how it works. And so yeah, I hope that makes sense. Okay, so again, within these kind of anchor brackets, this code now gets evaluated as normal Scheme code. And stuff that's in between, so how this actually works, and I will show you in a second when we get to the actual code of NSG, is it evaluates every even element. So this first thing gets treated like specially, so this gets read and then discarded. So the actual content starts after this first separator. So this first, and this is now empty in this case, this doesn't get evaluated. So whatever we write here doesn't get evaluated, but only gets treated as like markup, and which gets transformed accordingly. So the next separator starts the next block which gets evaluated. So this is now block 1, this is now block 2, so it's even, so it gets evaluated. This is now block 3, so it doesn't get evaluated. And if we add some more stuff here, for example, I don't know why these spaces are here. Do it like this, and then I don't know, 1 plus 2. This again gets evaluated. So if we transform this now and revert, we will see some 3 somewhere. Yeah, the 3 is right here. So kind of out of place without a tag. All right, so yeah, I hope that makes sense. Something I also wanted to show you is how to use org mode and markdown instead of my NMD. So how you do this is you need to specify the export type with stars around it. So star export type star, and you need to set it to either org mode or just org. It actually won't recognize org mode, so you need to set it to org or markdown. So first I will show you org, then markdown. And I mean, it's pretty straightforward. You simply can write org mode like you would write your normal org documents. So for example, this is a first level heading, this is a second level heading, and this is also a to-do. For example, to do some tasks, and this is some normal text with italic. And if we actually turn on org mode here, of course it won't recognize the first part, so it won't know what to do with this. But we can now, for example, and this is again in Emacs, of course, we can now, for example, fold these things or set this to, I don't know, done or whatnot, and do all this kind of stuff, or schedule this. Let's schedule it to today, I don't know. And if we save this now and we export this, so this is org.nsg, this is the file, and we use nsg.html to export this now, this will export it just fine. And if we open up org.html now, you will see that it actually, well, it is actually exporting, it is actually doing this just fine. So, and this is using, how I programmed this is by using pandoc. So this is using the pandoc program, so you need to have this installed if you want to use org or markdown. and it exports the first level heading, and you see it also adds IDs. So again, this is just normal org export by using pandoc, and it also does the to-do, and it adds like a to-do class and whatnot. Apparently it can't do the scheduled time with a pandoc, can't export that apparently, and it also does the italic tag or the emphasized text, and so on and so forth. So pretty straightforward. If you want to now, you can also export it with LaTeX, but of course you would need to change the layout thing. Okay, so now to use markdown, you simply write markdown here, and then you of course have to change the syntax to use markdown syntax. So second level heading and like this, for example. And we can also do this for italic, and then we would have to, we don't even have a markdown mode apparently. So no markdown mode here. And again, this is the same file still. And now we open up again, yes, and we see now it has changed, of course. So now the second level heading says second level heading. Again, it automatically creates IDs, so that is something that my NMD doesn't. And it's the same thing, but now with markdown syntax. So this is how that works. All right, so I think that was pretty much it for the like basic usage section. I will now show you a more complex example, and that is, in particular, I will show you my own website, which is of course also written in NSG, and it's a bit more complex. And I will show you a kind of truncated version of it. So if I switch to my browser, here I have it locally on my laptop. So it's my website, but it doesn't have all the content. So for example, I've taken out the articles and kind of replaced them with like test articles. So if I go here, you can see, it's kind of a test nonsense page. So if I now switch to that, and this is now included in the repository if you want to try it out, but I'll show you in a second. So let me actually switch to that. So we're not in demo anymore, but in tests, and then in examples, and then my website, and yeah, here we are. So the structure is again the same as before. We have these three component files, so comps, GMI, HTML, and tag, and I didn't put a like general comps file here. I think I have all the environmental files in all three files because I just copy pasted it kind of quick and dirty. But yeah, it doesn't really matter. Here we have the contents directory, and here a out directory where the actual output will be, and then an out.correct, because this is in a test directory, and they have to kind of correct solutions, quote unquote, which are used by the test, of course, in here as well. So yeah, but that's not really relevant for this. So let's kind of go through it. I will start with let's start with the tag, because that's the simplest one. It has the least contents in it. So again, output here, this is pretty straightforward. Base URL, this is now, I don't know why I specify this in the LaTeX thing even at all. This is not really relevant for this. Yeah, so whatever. We have, I will get to this in a second. Let's first go to this. So we have a layout. Again, it's a kind of anonymous function which takes a content. Well, this is in German. I don't know. I didn't change it apparently. So this just means content. And then we call string append. Here we have again a like string format, and we get the author. We get the date. Again, I kind of mixed German and English. I didn't apparently clean it up. I hope that doesn't bother. All right, so again, we set the author, we set the date. These are environmental variables. We set the title, and then we begin the document by first calling make title, and then calling table of contents if we have set the TOC variable. Then we just append the content, and then at the end we append the end document. So this is now an actual like LaTeX document. And this is kind of a separator. Yeah, so the separator in HTML looks like this. So this is this, but in LaTeX. And if we now look at the output file, so let's look at articles. like this one right here. Oh no, this is the GMI. Where is it? Tech. We can see, okay, document class, then author, date, title, then begin document, make title, and then, well, the converted LaTeX. And here's the kind of separator we specified in the comms.tech file, and so on and so forth. And we can now actually convert this to a document. Let's do this. So like this, and let's call PDF LaTeX. Yes. Out. Where is it? Articles. No, wait. Why doesn't it work? Okay. Out. Articles. Test2. Tech. And let's compile it 2 times. And if I now open this up, you will see it's an actual LaTeX document. Who would have thought? I mean, yeah. So this is now, this LaTeX document now corresponds to this HTML page. So the content is the same, like the NSG file is the same, but the output is, of course, well, it's a different output format, obviously. So yeah, this is why this is so great. And apparently I didn't specify TOC in the index file. And again, we can now look at the index, not index file, but at the source file. If we actually look at this, we will see the kind of markup I showed you earlier. Or not the markup, but the kind of structure. So at the top, we specify environmental files, for example, title and date. And then we have our actual content, which is in this kind of markup format I wrote myself. NMD is the name of it, but I want to show you that in a separate video. Then here we, for example, call a component. For example, this kind of separator component. It's called Stern because it's kind of in a like previous iteration of this. I used a kind of star symbol for it, and I never ended up changing the name. So yeah, that's that. And then we have some more content, and this is now syntax for small caps. And in the LaTeX output, you actually see the small caps. So this is in small caps, but in the HTML it doesn't render it because I didn't add it to the CSS. So, but it works fine, but it's just not styled correctly. So yeah. And if we look at the GMI output again, we will see the same thing. I think did I open it up? GMI. Yes, here it is. So it's the same thing. We have like kind of a title at the top, or a kind of, this is the same as this kind of line right here. Then we have the title of the article, then like this H2 and so on and so forth. And the separator, which, so in HTML it looks like this, in LaTeX I showed you a second ago, and in GemText, because we don't really have that much like options here, I just put like two forward slashes at the beginning of the line. So I thought about doing like some ASCII, like some, what's it called, monospace thing, but I just ended up doing like this, like for this example. And yeah, so, and at the bottom we now have links again, but these links are now, of course, not in HTML, of course not. So these links correspond to these links, but they are rather in GemText. So these are GemText links, of course, because if we look at the components file for that, so comms.gmi, we actually see, and we scroll down to the layout, where is it? We actually see that these links get added in this layout. And again, this is so nice because this is all just scheme. So what I can do is I can call string equals, and I can compare some environmental file, for example, to some string, and I know how it works because it's just scheme, because it's not some made-up scripting language, and made-up and limited scripting language. So this is really what makes it so nice. And I mean, if we add it, what's also so nice, and I mean, maybe this hasn't come through because I've switched a lot between files and so on and so forth, but you can now use all your normal scheme editing features in your editor. So again, here I'm using Emacs and Power Edit. So I can, in here, I can use, for example, I can go up this S expression tree by hitting Control-Alt-U. So to go up and up again and up again and up again and up again and so on and so forth. I can go down, I can jump over the next expression and all this kind of stuff. because this is just scheme. And I mean, I can do this in the component files, but also in the nsg files if I have like the mode enabled. So yeah, and what this enables is like very nice editing, very nice editing workflow, because you don't have to deal with some made up syntax, but you're just operating on S expression trees. You're just operating on Lisp code in the end. So yeah, this is very nice. And again, we can of course also look at the HTML for this. And the HTML template is now pretty big, because I mean, in this truncated version, this site is not very huge, at least not content-wise. But when it comes to like CSS and the styling and what I have included in this, so for example, there's a custom font here, so and all this kind of stuff. I have these kind of background images, these SVGs, and all this, like these animations and all this kind of stuff. This is of course now in here in this component file. So, oh yeah, and I also want to go through the listing of the articles in a second, but let me first show you so here we have the layout. And again, we call HTML. So of course our root HTML element is going to be HTML. And we set like a language, and then we have a head, and we set all this kind of metadata, blah, blah, web stuff. and here we set, for example, the CSS. And what you will notice, also I want to kind of mention this, if we go down to the actual HTML, so we have the body, we have the main, and here we have, for example, the header. You will see that I have specified these class attributes. And this is now atomic CSS. But it is not any like specific, well, no, it is a specific flavor, of course, but it's not Tailwind or Uno CSS, but this is my own atomic CSS version, which very nicely integrates with NSG because I've integrated it. So, and what this enables is to, for example, call the procedures from this atomic CSS engine in my NSG template. So, for example, I do this right here. So, if I zoom in, well, this is a bad example actually. Let's take this. This is a better example. So here I specify the CSS for the H1 elements, and instead of like going in here and writing the CSS out by hand, I mean, I've done it here, of course, and all this kind of stuff. But here I've kind of taken a shorthand. So I call the scheme function or scheme procedure matcher sm, which is now defined in my atomic CSS like library, and I call it with these arguments. And I mean, this is not really a procedure, but rather a macro. But I mean, that's just technical detail. And this will now insert the result of this call in this string format function. So in my, and this is another library I wrote, which formats strings based on these kind of pipe symbols and whatnot. And yeah, so what I want to say is, I mean, even if that doesn't make even if that now doesn't make much sense to you, I kind of want to show this aspect of having no fragmentation, of having everything like nicely integrated. And the reason for this is because I wrote it all myself, and because I have taken care to, well, actually integrate it. So yeah, but okay, let's get back to like NSG and kind of showcase why I wrote it like that and why I really like it. So let's take a look at the articles page. And this is something very common if you have like a blog or whatnot. And I mean, articles and blogs kind of the same. So you have like a listing of different subpages, and you kind of want to have the listing. You kind of want to have the listing to be automatically. Obviously, I mean, you don't want every time you write a blog post, you don't want to manually add it to the list. This would kind of be very tedious. So I have, if I scroll up a bit, I have this. Where is it? Yeah, this list link here. It is now quite complex if you look at it, because it does a lot of stuff. But in its core, all it basically does, or the core call is this directory call right here. And this will now give you all the file names in this directory. And this directory is based here with the stars, because this is an environmental file. This is an environmental variable which gets automatically set by NSG. So if we call nsg.html on this let's do it nsg.html on contents articles index.nsg. Base dir will be this contents articles part. So if we call directory on that, we get a listing of all the files in this directory, which we can then use and transform into a listing of the articles. And for example, so right here I sorted alphabetically, and then I transformed the date, so I can sort it alphabetically, so I can have a listing by date. So this was released before this one, chronologically, and all this kind of stuff. And if you look at this, there's a lot of kind of quasi quoting. So the surrounding thing is this div, then we have this unordered list, then we have a map call. So this is again scheme. Then we have sort, then filter, then again let, and then in here we have sxml again. And so this is kind of very convoluted. So, and may not be very easy to wrap your head around at first, but I of course know what's going on here because, well, I have written it. And yeah, this is again a very complex example, but one that's, well, real life. So something else I do here, for example, is I look for an draft environmental variable. So again, this is in German, so in German it's Entwurf, but this just means draft. And if this is present, we do not list it. So, and I can kind of show you how it works. So let's go into articles, and let's go into the second one. Let's go up here and set like this. And if we now regenerate this and look at our browser again, we will now see the second article, the second test article is gone because we set the draft environmental variable on it. And again, you can call this whatever you want. This is just the one I use. Or, well, I've used in this thing and never changed it. But what I want to say is, this is now not dependent on the application you're using on NSG in this case, but this is rather just application logic, or the logic of your site actually, because you write it yourself. And I mean, of course, is writing like a giant like function which does all this logic like by hand, is this easier than having some built-in logic in the site generator itself? No, of course not. But it gives you the control, it gives you all the control you need, is what I want to say. So you can do whatever you want and you understand what you're doing. So the generator doesn't get in your way in this sense. All right, so I think I've talked enough about like this kind of real life example. Okay, now I want to quickly walk you through the code base. And I don't want to go into everything, but I just want to give you a brief overview so you can have a starting point if you want to dig into the code yourself and understand how it works, change stuff, and so on and so forth. All right, let's go into here. And here I have the directory for the NSG repository. And now the important files, I mean, there are a lot of files in here because I've installed it, and it creates these SO and these O files. But what we care about in the beginning is, or what I first want to show you rather, is this nsg.egg file. This is now the chicken scheme egg definition, and then egg and chicken scheme is basically just an extension or also a program. And we have 4 extensions in here and a program. So we have the extension, the core, the nsg.core, nsg.html for the HTML export, then .tex for the LaTeX, and .gmi for the gemtext export. So, and then we have the program nsg, so the actual binary itself, and it needs all these, it has dependencies on all these components. All right. If we look at the actual nsg.scm file, so the actual scheme code for the binary, we will see that it imports a lot of stuff because I couldn't get it to work without calling eval on import, because I call eval when evaluating the actual like code of the content files. And without having this block, I wouldn't have access to all of these modules. So I, for example, wouldn't have access to, I don't know, chicken sort, so I couldn't sort stuff and stuff like that. So I needed to do it like this. So it's kind of ugly, but it works, and I mean, yeah, it's fine. And so this is now the actual entry from the binary. So if you call the binary, this code right here will get run first. And what it does, it looks at the program name, and it looks at, okay, are we calling nsg.html? tech or GMI, because I think I said in the beginning, I mentioned it briefly, I have syslinked, or not syslinked, symlinked the NSG binary to NSG HTML, tech, and GMI. So the differentiation between what do we want to convert to is only based on the program name. So I think that's a bit nicer, a bit more elegant than having like a command line argument. And then we call the corresponding procedure. All right, and if we give the hyphen as the first argument, it reads from a string. So yeah, this is kind of the logic of that. All right, next up, I want to quickly go through the core because, well, that's kind of the core. Let's go up here. Again, we import a bunch of stuff. This is now a module, mind you. And this is now kind of the core, well, the core, yeah. So we have an environment. This is now the global environment. So everything kind of revolves around this. So in here, all the variables which get set in like the kind of header section of the content files and also in the components files, this is where all of them get added to, or removed to, or looked up in. Yeah, they get looked up in this environment variable. So this is by default, or at the start, it is an empty list. These are just helper procedures to avoid code duplication. This is now the thing we called earlier from our scheme code, or from our component files also. This $sign this is not now a procedure technically, it's a macro, so we can avoid having to quote the symbols we look up, if that makes sense. And it just calls this helper procedure, which looks up a certain key in our environment, in our star env star. All right, this does the same thing, but it also evaluates the thing we look up. So this is for procedure calls. So the example I give here is title and then with a hello world as an argument. So this is a constant, so it doesn't need to be evaluated. So this is now fine. Again, because this is a macro, it doesn't evaluate arguments. But if we want to evaluate arguments, I mean, and I have this whole comment block about this $sign period, about $sign dot, you can call it, because this now doesn't evaluate the result right away, but you can evaluate it then yourself. So for example, you can call it like this. And this is kind of the same as calling eval on the $sign thing. I mean, yeah, you can read through this, but this is kind of, this is core functionality, I would say. Or not I would say, but it is. Okay. I also have procedures, of course, to add to the environment, to set some value in the environment, or to delete from the environment. So yeah, this is what these are for. I mean, these are pretty straightforward. All right, and all of the rest, I don't really want to get in directly, but I rather just want to, because I think it's very complicated to think about it abstractly, but I want to rather show you an actual like export export functionality. So we will look at the nsg.tex module. So again, it is a module. It imports a bunch of stuff. So for example, it also, or what's important here is it imports nmd.tex. nmd is my markup, my own markup library. It imports that because it needs it, because we want to convert from nmd to tex, of course. All right, and there are now three and a half kind of important procedures here. Oh, let me zoom in. So the first procedure that gets actual, or the two procedures which get called, and let me kind of put this side by side. So nsg.scm, because if we look at this is again nsg.scm, so this is the binary, this is the code for the binary which will be run when you run the binary. If we look down here in this case statement, or in this const statement rather, it checks if the program name is nsg-tex, and then we look if we want to read from string or from file. It gives these two procedures: convert string to tex and convert file to tex. And these two are now defined right here. So this convert string to tex is defined right here, and convert file to tex accordingly right here. So this is what actually is being called here. And accordingly, this convert string to HTML and convert file to HTML and convert to GMI are defined in the nsg.html.scm and nsg.gmi.scm. Okay, so but what are we actually doing here now? So let's look at the file, because I think that's a bit more intuitively clear, maybe. Maybe not. Okay, so first we add to our environment the target is tag, and this is now the symbol tag. So this is important for the logic of the application. So we add this to environment, and yeah, next up we prepare the environment from file. We give the file name, so this will be whatever you specify on the command line. So for example, if we call nsg tech and then content index.nsg, this f will be content index nsg. Yeah. All right. And it now calls this prepare end from file, and this is now defined in the core. So if I switch to nsg core again, and we look at prepare env from file, this is now the procedure which is called here. And this is very complex because it needs to do a lot of stuff. It needs to look at output directory. It needs to look at do we have a parent? Which component files do we need to include? It does, again, a lot of stuff. It also needs to look at the export type and all this kind of stuff. I've tried to kind of document what each line or what each expression does. So if you want to dig through it, I think you can, hopefully, if you're interested. But yeah, I don't want to go into that right here, because this is just going to be this is only meant to be a brief overview. All right, and if we convert a string to tag, it calls this prepare end from string, and this is defined above, I think, and this is a bit simpler. So this is a bit simpler to wrap your head around, because it doesn't need to think about directory structure and where to write a file to and all this kind of stuff. All right, so first it does this. It prepares the environment, and you can see if you look through here that, so for example, we add the file name environmental variable and extension and base tier. We add all of this to the environment. So this is also, all of this is available in our site, in the site we are creating. And I've also showed you the base tier can be, for example, used for a article listing or blog listing. Yeah, so this is that. And then it calls convert file. And this convert file is now again defined in the core. It gives either it gives a string if we are converting from string, or it gives the file name again. So again, this would be content/index.nsg, for example. And it also, and this is now specific for the corresponding output or export format, so in this case LaTeX, we give a procedure, so this is a key argument, and we give the procedure process tag content. And again, we can kind of look for convert file, where is it? Output to file. And this is very, well, no, this I think isn't too complex, but I don't really want to go through it here. But rather, so the important thing is that at the end we call, we call this convert file, so this one up here, and here somewhere we call process content. This is it. So process content, and then the content we pass it. And this process content is now what we specify right here. So this process tag content, that makes sense. And if we scroll up here, we see that it's actually pretty simple. It's a procedure, again, which takes one argument, content, and then it looks if there is a layout defined. We kind of wrap all of this call, we wrap in the layout, and if not, we just call identity on it. So we don't really do anything with it. Oh, no, we don't do anything with it. We just give it back as is. And this call right here is kind of the next kind of core call. So we pass this content to this import file to tag. And this again is a procedure defined down here. And this again wraps a procedure defined in core, in particular this, or in this case, this input file. And if we look at this, this is also defined somewhere, yeah, right here. And this is again a bit complicated. I've tried to document it with comments to show you what it does. But the most important thing here, what it does is it calls this eval even proc. So right here, it calls the procedure eval even, and it gives it a list, and this list is now the contents of our file or our input string split based on this pattern right here. And if you remember back to when I showed you examples, this is the kind of separator we use to separate the different sections of our content. So sections we don't want to have evaluated, so we only want to have converted from our markup to our output format, and then sections which we do want to evaluate as scheme code. So this separator is, I think it's only defined in this place. So if you want to change it to, I don't know, something else, you can change it. You can just change it right here and it should work, I think. So we split our content string on that. And then we don't care about the first element because this is the environment and we have already taken care of that. And then we pass it to this eval even proc. This again gets passed to this input file procedure. And in particular, it gets passed here. So eval even to deck. And we also, for example, we specify the output format here. So next up, we want to look at eval even to tech. And this we can see right up here. All right, so this is now, again, a wrapper function. All of these are wrapper functions in this nsg.tex.scm. And if we look at the nsg.gmi.scm and nsg.html.scm files, we will see the same pattern. So we only wrap procedures which are defined in this core.scm. And right here we wrap eval even. So if we look at that, eval, where is it, even? Right here. This is again a bit complex procedure. This is now also a recursive procedure. So down here it calls itself with all of its arguments. And this now goes through the list and, well, evaluates every even argument, as the name would suggest. So, and we pass this odd wrapper procedure because if we are working with NMD markup, we want to directly convert it. And if we are working with markdown or with org mode, we want to only convert it at the end. So where we convert org mode and markdown is in this input file. So right here we call pandoc to convert these to our final output. So this is the pandoc call right here, and then we write string to this pandoc process. I hope that makes sense. All right. So, and this is, yeah. So this is for that. This org escape is if we're using org mode, we need to actually escape escape LaTeX code and also HTML code. I don't know if Markdown can actually include LaTeX, but Markdown can include HTML. So this is why there's only an org escape argument right here. Because again, we need to wrap LaTeX code and HTML code for org mode to be able to convert it at the end. So yeah. Yeah. So I hope that makes sense. maybe not. All right, so yeah, that's basically all there's to it. I mean, of course, this is now very complex and all of this stuff, but I hope I was able to give you an overview of how it works in principle. So you can, if you want to, you can dig into the code yourself and find out exactly what it does and adjust it and all this kind of stuff. And again, if we look at the gmi.scm, we will see the same pattern. So we have the eval even wrapper here, we have the input file wrapper here, the convert string and convert file wrapper here, and the the process GMI content procedure right here. This is now a bit more complex because we also need to handle footnotes and links. Yeah, I mean that's a whole nother thing, but yeah, it's more complex than LaTeX, and that is why I wanted to only show you the LaTeX thing and not the GMI or HTML files, because these are a bit more verbose and complex. So with HTML, for example, we need to convert from SXML to HTML and all this kind of stuff. We also need to handle footnotes, and we also need to org escape. So we need to escape our HTML code if we are using org mode instead of NMD, and so on and so forth. So yeah, I think that was enough for code walkthrough. I hope that made at least a little bit of sense, and you were able to kind of grasp the structure of the program. So again, all the operation logic is defined in the core, and these modules for the different output formats only wrap the core procedures and pass the corresponding arguments and set the corresponding environmental file. So for example, down here it sets the target environmental file, env variable, to HTML. So yeah, all right. That was a lot of stuff. Next up, I also want to show you installation and then some closing thoughts. So if you go to my website and go to code, you will see all my Git repositories. And you need all of these, the first 4 repositories, the other 2s are other projects, but you need all my chicken scheme libraries. So let me think how should I do this? Let's go here and let's go to my home directory, make a new demo directory, demo libs, and now we need to git clone all of these and install them. So, and the git clone URLs are in the git, like on this website. So we need to git clone the nsg program. We need to also cd into our demo libs. Let's clone it. Let's clone also mwd. So this is, I haven't mentioned this. I think I mentioned it briefly when I talked about my website, about my actual website. This is for like minimal web dev procedures and kind of this stuff. This is also needed because nsg imports all of these and builds with them. So we need to also clone this. We need to also clone nmv, which is my markup. And we also need to clone ff, which is my string format function. So now we have 4 directories, and we need to now build all of them by calling chicken install -s. And if you're using sudo like I am, you need to prefix that with sudo equals -s. Oh yeah, and I totally forgot, you of course need to have chicken scheme installed. And I have a introduction video to chicken scheme, so if you're interested, you can watch that. But as it is now, you need to have chicken scheme installed, and because you need to build it from source, because I don't really have binary distributions yet, but I might add them. I will look into that. But as it is right now, you need to build it from source. So you need to do this. And I mean, I don't really want to go through all of this right now. Well, no, maybe let's just go through this. I mean, if you want to, you can of course skip forward. I will have timestamps, but it's pretty straightforward. You just cd into the directory and then call this chicken install command to install the library or the extension, or at the end, of course, the final binary. So yeah, I will skip forward when this is done. Okay, so MWD is also installed. Let's go into nmd, MWD, yes. So, and let's also install this. I will again skip forward. All right, and finally we can now install or compile and install nsg. So again, chicken install s. And I also want to mention, if you have not installed any other chicken libraries, it will automatically fetch all the dependencies, or it should automatically fetch all the dependencies. So for example, some string library, so srfi13 or 1 or whatnot, also utf8, it will fetch all of them automatically, or at least it should. I think all of this should just work, hopefully. So installation is done. So we have now, and if you call it like this with the s flag and with like sudo dois, or if you use sudo, this will now also install it right away. So if we call which nsg, it will install it in user local bin, or whatever you have set your, if you have installed chicken differently, it might have put it somewhere else, but this is the path for my computer right here. And if we now ls, I have also this kind of long named script, because as it is right now, you don't have you wouldn't have nsg.html because this is a symlink and you need to create them manually yet. I haven't found a way yet to automate this with the chicken install thing. So you need to create symlinks, and let's look at that first before we run it. So it's a shell script. It gets the path of nsg, and then it symlinks them to, or it symlinks it to -html. So nsg-html, nsg-gmi, and tag. So if we actually run this, it will tell us file exists, and you would need to run this as doers, by the way. So you can actually write to the user local bin user local bin. So yeah, but it tells me file exists because I have done this already. And then you have these nsg.html and so on and so forth. So yeah, and now you've installed it and you can actually use it. All right, now I want to share some closing thoughts for the end here. So first I want to kind of talk about the future and kind of things I'm thinking about for this. So yeah, and then I will share some more general thoughts. All right, so the first thing is speed improvements. If you try out NSG, or as you might have seen in the demo, it is, I mean, even though this is an older laptop and I'm recording the video simultaneously, but it is still very slow. And this has to do with a lot of things. It primarily has to do with me not caring that much about speed, at least like in the beginning so far. And one thing is, of course, that you can't convert multiple files at once. So for each file you want to convert, you need to call the binary. And this is, of course, a pretty big overhead. And it would be very easy to like convert multiple files at once. I just haven't programmed it yet. So that's one thing. But another thing is also that for like a blog listing, for example, you read in every file, like every blog post, to see, okay, is this a draft? Okay, when was this published? And because you need to sort it, of course, and stuff like this. You need to display the title and whatnot. And for a normal blog listing, this might be fine. But if you have like a lot of files which reference each other, this, I think, becomes very inefficient and very redundant. So I've thought about implementing some kind of cache for files which get read in, or of which the environments get read in. So I might also implement that. But again, speed is a big thing, and I've noticed on bigger projects which have like a lot of pages, this really becomes a problem. So yeah. And I have also been thinking about like binary distribution, because as it is right now, you need chicken scheme installed, you need to like clone the repositories, compile it yourself and whatnot. But I'm not quite sure on that yet. I mean, I will probably try it out and whatnot, but I think the whole ethos of this project is really one of you probably want to like know what the program is doing. You probably want to like kind of dig in, adjust stuff and whatnot. And for this a binary distribution wouldn't make that much sense, I guess. But otherwise, on the other hand, like a binary distribution makes it very easy to try something like this out. So without having to install all the dependencies. So yeah, I'll see how I do that, or if I do that. All right, so now to more general thoughts, because writing NSG has actually been very rewarding for me. So I wrote it at the start of last year, so start of 2025, and I've been using it the entire last year. So, and the first version, that is. So this is kind of the second version. And so the first version only exported from org and markdown to HTML. And now I've kind of expanded this, as you've seen in this video. And I have used it for all my projects, for all my web projects, and yeah, it has been honestly very, very good. I've then, like later in that year, I have added the MWD thing, so the minimal web dev procedures or whatnot. So the atomic CSS and also the kind of scaling and whatnot, if you look into that, and also like colors, dynamically generating those, and like it only got better. Like my web dev experience, quote unquote, only improved. And yeah, I don't know. I've never looked back, to be honest. Like not at Hugo, not at like org mode, and like exporting that to HTML. I mean, I've done that in the past. Don't get me wrong. Like I even had like a I even had on a server I had a headless installation of Emacs, and I had a script which that headless Emacs would run to generate the page from the org modes file, from the org files. But I mean, that sounds kind of weird and was, and yeah, I just kind of scrapped that idea because that's just not what Emacs is made for. And since org mode is tied to Emacs, yeah, so. But okay, but back to NSG. So again, very rewarding quote unquote experience, I would say. And I would encourage you to, if you need to do a lot of web development, you probably want to write your own static site generator if that is what you are doing. So generating static sites, because I think it's important to have like complete control, especially if you're doing like it like professionally. Yeah. So I think that's it, and it was also very fun to have something to tinker with, like to be able to like go in and oh yeah, I need that feature and let me put that in and whatnot. So yeah, that was very great. And also I kind of want to kind of talk about like more general themes, because of course you might look at NSG and think, well, what is this? I mean, it can't do X, Y, and Z. Like this is pretty useless, and for you it might be, for your use case. And what you need to write, like kind of block directory listings, you need to write those by hand and whatnot. I mean, yeah, you can look at it and like look at it from that point of view, from like well, the program should do everything like by pressing one button, and it should generate my whole page automatically without me having to specify anything, specify any layout, and it should have a default layout and whatnot. But I think this restriction actually, like in my case, it leads to more freedom, of course, and more control. So, and I've talked about this in like other videos, and also I've written about that in articles and whatnot, how that works. So I don't want to repeat everything here, of course, but this is just like a real life example for this, or how could you say, a manifested example of these themes for myself. So I have gained great freedom in that respect, because I'm not now dependent on like some developer team which develops the generator I'm using, and they change something there and they have a break-in release then, and oh no, now I need to worry and I need to kind of change my stuff and whatnot. Like when something breaks, and a lot of stuff has broken with NSG, like I've adapted it quite a bit, and probably more will break in the future. And break, I mean changes which kind of need adaptation of older projects. But it is me who controls this. Like I am in control. I don't need to worry about like some external force. And I mean, of course, this is based on Chicken Scheme, and you could say, well, you're still dependent on the Chicken Scheme developers. Yeah, okay, sure, in some abstract sense, I guess. But a programming language is so much more stable than like a program. I would argue. So, but I guess you could argue, well, you need to write your own scheme to kind of gain full complete control over the stack or whatnot. I mean, yeah. I guess that would be a next step, but I don't know. I don't think I'm going to do that, because that's just a bit much of an undertaking, I would say. Well, with Scheme, I guess it's doable, but still. So yeah, I hope you kind of catch my drift with the whole freedom control restriction thing. So yeah, I think that's just, and I think this is the main selling point to me for my own project, that I have written it, and thus I have complete control over it. Like if something breaks, I might not immediately know where or why, but I can dig in. I can kind of I can find my way in my own code base. So yeah, it's very easy to fix stuff, to adapt stuff, to add new stuff, and stuff like this. So yeah, if you are interested, you can try out NSG. I've shown you how. But again, more than that, like I don't really, like, if you try it out, if you don't try it out, that's not my point. Like, that's not really important to me. I think my point is rather, if you have, like, if you need to do something a lot or professionally, you should write your own stuff. If it's not too complex, of course. And a static site generator is not complex. Like, it appends strings. Like, that's all it does, really, if you boil it down. So yeah, it's really not that complex, and I think everyone can write one themselves if you want to, of course. So yeah. All right, so I think that's it for this video. I think it's long enough. And I hope I haven't missed anything important. I think I've gone through everything that I wanted to. So yeah, that's it. Have a nice day.